There is no machine that is a 100% efficient. And if you could invent that machine, you would be very, very rich. What we're trying to do is improve our efficiencies, but we're not there yet. The efficiency that we have is usually recorded as a percentage. And to get there, we simply take the amount of energy that the machine puts out and compare it to the amount of energy that a machine puts in. That'll give us a decimal, and then we just simply multiply it by 100% to get the efficiency. We can also calculate this, the same thing, based on the power a machine has. The out compared to the power that's put in. Once again, multiply it by 100%. Please note that some people will use zero, what looks like a zero, but it's actually an O. And sometimes it looks like an L, but it's actually an I. So instead of writing the word out and in, it's I and O. Just be very cautious. Here we go with a couple of examples. So if a machine uses 84 joules of energy but only completes 62 joules of work, what was its efficiency? Very simply, its efficiency would be the work out, which was the 62 joules, compared to the work put in, which was the 84 joules. Don't forget that that's going to give us a decimal that we multiply by 100 to turn it into a percentage. This one, that looks to be around 3/4. With my calculator, I see 73.8% efficient. Please note that the units here, the joules, cancel each other out, and we're left with units of percent. Sadly, some of you are not very efficient at getting your classwork done. So if you put 3.6 joules of energy into your efforts, how much work did you actually do? Well, we know that 45% is the work out compared to the work in. And you put 3.6 joules of energy into it. So let's see, 45%. And let's see. You're 45% efficient. Yeah, okay. So the in you put was 3.6 joules. So the workout, let's make the little O, is 0.45 multiplied by 3.6 joules. So the work that you're getting out of this is roughly 1.62 joules.